Hello students, welcome back. Let us resume our discussion on section 3, geometric preliminaries. Previously we discussed lines. The next topic, circles. I don't know whether this is going to be useful in this course. I think it's not going to be very useful. Circles are coming from the distance formula. As you can see, here we have this Pythagorean triangle, and distance is hypotenuse between this point x1, y1 and x2, y2. So hypotenuse squared is horizontal squared plus vertical squared. Horizontal is run, vertical is rise. So the difference of x coordinates squared plus difference of y coordinates squared. And then if you take the square root, you get the distance. It's coming from Pythagorean theorem. Now, use this distance formula to get an equation of a circle. Because what is a circle? It's that of all points that has the same distance from a certain point, the center point. So all the points on this blue circle, x, y in general, has distance r from the center, x0, y0. So the distance is r in the distance formula. Of course, I don't like the square root. So square both sides to kill off the square root, and that's what we get there. So this ends up being the equation of a circle centered at x0, y0 with radius r. Now, how important is this? I'm not so sure. It is important in trigonometry-based calculus classes because all trigonometry coming from circles, so it's important there, but I'm not so sure whether it's important here. I de-emphasize it in gray. Now let's talk a little bit about crossing points. This too, I'm not so sure how important it will be in this class. Let's talk about it a little bit. Equations and curves, okay. And any algebraic equation of x and y tends to be either a curve or several pieces of curves. Here's an example. This thing is an example of a curve called Descartes' folium. Looks like this. It's a one piece of curve like this. Okay, and then of course, if you get different equation, you're gonna get a little bit different curve. Let's see, let's have a little bit of fun. I don't want to change this, so instead of this, let me change it. It didn't change much. This is where it was. Let's see. That certainly will change things a lot. Oh, it did not. Not by much. Okay, there you go. I see some change. Make it bigger. Okay, I can clearly see now we have two separate pieces of curve coming from a single equation. So, what's the moral of the story? You may need some technology help, but it turns out that an algebraic equation of x and y often form a curve or several pieces of curves. Now, what if you have more than one equations or a system of equations? For instance, this equation blue and that equation red. In that case, the solution of this kind of system of algebraic equations represent the point where both of these equations are true, but this equation is a curve or several pieces of curve. That equation is also a curve or several pieces of curves. So when both are true, they are crossing points. So this blue represent these blue curves. They're two curves. Red represent this curve, a circle. And as you can see, there are 4 crossing points. 1, 2, 3, 4. Do you see? So that means there are 4 solutions of this system of algebraic equations. You can actually solve those, but that's not what I'm going to do here, even though it is possible. So I left it for advanced students. If you're interested, go ahead and see. And without even technology aid, you can actually get it done. But that's where I'm going to stop as far as circles and crossing points. Now, there are some additional topics, but those are a little bit different. So I'll talk about those in a separate video. So circles and crossing points, they're done, and let's stop here for now.